Hey, hello everybody. Thank you for joining, and in particular, thank you to our speaker, Yoann Padioleau. I'm trying my best. And today, Yoann is going to talk about Semgrep, which is a tool to express rules for identifying bugs on code. And I think a couple of interesting facts are, well, first of all, the fact that it supports 26 different languages. And the second fact, the fact that it lets you express rules in a very simple way with example of code instead of having to learn how to build an ABSA syntax tree or learning some specific DSL. There are different ways to use Semgrep as part of the CI, as integrated in your editor. And there is also a playground that I guess that Yoann is going to show at some point. And Yoann is currently working at R2C, a company specializing in security and ensuring quality of code and reliability. And is the creator of Semgrep, the tool that is going to present. And this tool is being used by a lot of large companies, including, among others, Dropbox, Slack, many others. Before that, he was working at Facebook, where he's created the group on static analysis, if I remember correctly. And before that, he got a PhD in RAN, and he worked on Cosinel, that is one of the software developed at INRIA, I guess, if I remember correctly. And he'll also love to program in OCaml, so that is another thing to consider. So now I think it's time for me to shut up and let Yoann take over. Thank you, and we're looking forward to the presentation.
Thanks for the introduction. So I had a few slides at the beginning to say what you just said, so I guess I'm gonna skip them. And okay, can you see my screen? Okay, yes. Cool. So yes, so I'm gonna talk about Semgrep, which is a polyglot customizable bug finding tool. So it can do lots of things, but its main focus is bug finding tool, and especially security bugs. And so yeah, a few words about me. I'm a software engineer at R2C, which is a startup that is based in San Francisco. Actually, now lots of us are working remotely. Actually, I work remotely from Italy, and our mission is to profoundly improve software security and reliability. So that's the mission. Actually, in a few weeks, the company is going to be renamed to just Semgrep, because our main product was Semgrep, and so we're going to rename the company for marketing purpose to to Semgrep. So and yeah, before R2C, I was a software engineer at Facebook, where I started the test engineering, what we call now AppSec, the AppSec team, so application security team. That is now, most companies now have an AppSec team that is responsible for trying to fix bugs before they arrive, like enforcing security rules before the company is in trouble. And I started there. I was also a founding member of the program analysis team. Actually, I was the only member of the program analysis team for a few years. Now, actually, there's lots of people, lots of great people in the program analysis, doing program analysis at Facebook, now Meta. And so, yeah, so a TLDR on Semgrep. So it's a customizable, lightweight static analysis tool for finding bugs. It comes batteries included, meaning that when you install Semgrep, you will have access to hundreds or thousands of rules for many languages, for many frameworks. And it's combined the speed and customization of grep. So it may sound weird to talk about grep in a static analysis context, but I will explain that later. And it combines the conveniency of running grep in the command line with the expressiveness of a real static analysis tool. and it can be run offline. It doesn't require the code to compile, and it's fast, and it's actually open source. And so, and like Federico said, there's no, I mean, there is a DSL in some sense, as I will explain, but it's pretty easy to write rules because the code patterns look like real code, look like regular code. And so, as said, so now actually this is an old slide. So all the languages that are at the bottom that used to be in are all already working, all of them. And now we actually have 7,000 GitHub stars. So it's one metric. And so, yes, the outline of the talk, I will talk about grep and abstract syntax tree. I mean, given this community, I will probably go fast on this section because you're all very familiar with this field. And then I will do a demo of how to use Semgrep. Then I will talk a little bit about the ecosystem around Semgrep. So Semgrep is a command line tool, but there's a what we call the registry. There's integration with your continuation integration. There's a web application, but this is not a commercial talk. So I will try to go fast and not force you to pay us to run Semgrep. And then I'll try. I have a few slides that I'll try to talk a bit about language engineering. And so I will try to talk about tree-sitter and how we managed to handle to handle 26 languages, and the parsing issue and the naming issue we had. And so actually I saw in the discuss community of Strumenta yesterday, I saw there was a question on tree-sitter. So hopefully that will answer a bit. And so yes, grep and abstract syntax tree. So very quickly, so let's say you want to find all the code to exec in Python. And so exec is dangerous security-wise. And so many AppSec people, like in a company, they want to find all the places in the code where you call exec because it's dangerous. And so, and I mean, one of the tools people, developers like is grep actually. And it's bad, but in some sense, it's also good. I mean, it's pretty convenient, it's pretty fast, and it's pretty powerful. I mean, and so if you want to find all the code to exec, you can run a regular expression like this one here. Can you see my cursor? Yeah. And so you look for grep -e with exec and then anti/ open parenthesis, and it will find all the code it will find the first one, it will find the second one. And then the problem is that it will not find the third one, right? Because there's white spaces between the parentheses and exec. So you could extend the regular expression to handle that. You can say anti/s for that is a special code for white spaces. And so that will handle this case. But now, like if the call on exec is spread over multiple lines, doesn't work anymore. Your regular expression, again, you could extend your regular expression to handle that. But then you also need to handle the fact that method suffix, like if there's other exec, it will find it, and you don't want that. If it's inside a comment, doesn't matter, but it will actually find it. If it's in a string, again, it will display. So there will be lots of false positive and false negative with the regular expression. And so yeah, regular expressions are great, but they're quite fragile, and it's very like it's very convenient at the beginning, but as soon as you just like realize that, my God, how I'm gonna extend this regular expression to handle correctly what I want to look for. And there's a reason for that, because grep is great for finding strings, but code is not a string, right? It's a tree. And so as you are all familiar, so on the left, we have the code as text, but internally, it's really an abstract, it's really a tree of expression and declaration and statement. And so there's a big inadequacy with the grep tool and a tree. And so actually, there's lots of what I call tree matching tools to find bugs. And so like here, I've listed a few ones. So Bandit is for Python, dlint, ESLint for JavaScript, Flake8 for Python, golint, gosec, pylint, rubycop, tslint, and more. So there's lots of linters that allows you to write rules to find bugs, but each time you have to become expert in every abstract syntax tree for every languages your team use. And it needs a bit of programming language expertise. Not a lot, but still a bit. So just for like the situation is far better now than it was 20 years ago, right? Like 20 years ago, you could not even do that. You wanted to write rules for C, you will have to modify the GCC compiler that was never designed for that, right? In the last 20 years, there's been a huge amount of progress where the people designing language have separated the front end from the back end and made it possible to reuse the front end to do different things, not just to compile, but also to find bugs, to like I guess you're familiar with the language server protocol server. So there's been a huge amount of progress there, but still, it's like if you want to modify the front end of those languages, you need to be a bit an expert and you need programming language expertise. And so on the right, actually, I've shown the lint rule for Python to find calls to eval, or it's JavaScript actually, maybe. Yes, I think it's JavaScript, the JavaScript linter. So it's not very long, it's 300 lines, but it's still 300 lines, right? So it still takes time. So if you need to write 100 rules like that will take time. And so you could also, like the alternative to grep and do linters is to use a commercial static analysis tool, like Coverity, Fortify. But they are also very complicated. They are very slow. They were not made for this new world we're in, where like you developed on GitHub and you have CI, and so they're also very expensive. Yeah, so landscape is like on the left, you have this regex based tool like grep, which are very easy to use, but quite dumb. And on the right, you have like whole program analysis tool they're very complex and very, very expensive and very slow, etc. And in the middle, you have these linters, these EST based lints that are in the middle, but they're still not as convenient. And so the goal of Semgrep is to be here in the middle, to be basically an EST-based lint, but with the conveniency of grep. And so I forgot to mention, but yeah, if anybody has questions in the middle of the talk, don't hesitate to aggressively interrupt me and stop me, and the talk will be better that way. So yeah, and so that's the scope, the context of Semgrep. And so I'll do a few demos of Semgrep and presenting the main features of Semgrep, but I will not have the time to present everything. But hopefully you'll get a good idea of the tool. And so to take back the example that I've shown previously, so let's say you want to find all the calls to exec, right? And so how do you write the rules to find all the call to exec in Semgrep? And so I'm going to go directly to the solution here. And so can you see the screen? Okay, so a little bit of introduction. So this is a playground for Semgrep that is on the web, so that it's easy for newcomers to test Semgrep, and it's also very good for filing bug reports, etc. But you can also use the command line tool to do the same thing. But the playground is a great way to get started. And so on the left part here, you have what we call the pattern or the rule, that is what you want to look for. And on the right, you have what we call the target code, regular test code, basically. And so here we have some Python code where a few calls to exec, the same that in the slides that I've presented before. And here you write the pattern. And so the idea of Semgrep is that to specify a pattern, you just reuse the syntax you already know. So you already know how to specify a function called in Python, right? You write the name of the function, parentheses, open parentheses, closing parentheses. That's it. You don't need to know what is a node name in the EST for a function call. Is it call, apply, whatever? Like you already know the syntax to specify a call. And so here you use exec, and the ... is the ellipsis is a special feature of Semgrep, which means a sequence of things that we don't care about. Okay. And so once you specify the code pattern, here you type run, and it will show you all the places where it matches. So it matches there, it matches there, even if there are some spaces on multi-line. It doesn't care about code that is in comments, and it doesn't care about code that is in string. And so the idea of Semgrep is that you use the concrete syntax But internally, the tool is using abstract syntax tree and abstract syntax tree matching, so that internally, the tool will not care about spacing like here, or multi-lines, or like it will know that it's a comment. So it will work at the EST level. And one thing to note actually is that, so here, for example, the exec was renamed as other function, and we'll still report it, because even though it's not textually the same thing, it's semantically the same thing. That's why it's called Semgrep, for semantic grep, because Semgrep knows about the semantic of the language, and so he knows about when you do an import like this, this is actually a call to exec. It's called other function, but it's really a call to exec. And so that's the main idea of Semgrep. And so I show the playground. So here at the bottom, actually, you can also install Semgrep on your machine and run the command line tool Semgrep -L for dash language Python, and then you do -E to say the expression, the patterns you're looking for. So here exec ... and then you put a file name, and it will report the matches in this file. Actually, you can also put a directory like dot, and then it will recursively go through all the Python file in your project and apply and look for this pattern. Okay. Is there any question at this point?
I'm not sure whether this one should be for later, but what's the largest amount of files that you've successfully run this over? How big a code base can you cover?
So, I mean, we've run on mono repo like Elasticsearch, or like, and like I said, it's used by many companies like Netflix, Dropbox, who have internally huge code base, huge mono repo,
Okay.
And it's pretty fast. I mean, the reason it's pretty fast is, but I should not say that, but the reason it's pretty fast is because it doesn't do much actually. It's not like it's doing like complex program analysis, like whole program analysis. It's just like running actually in parallel on many files, the matching engine, and so there's not really scaling issue. So it's pretty fast, and it's just parsing. Yeah, go.
So it's to find something and that's it, or more.
Sorry, what?
Is there as a grep that says to find something, or sometimes with grep you pipe that into the ability to change something? So
yes. So I'll show it. I'll show it later. There's a way to also fix the code that you found. I will try to show it later. But still, the main use case for Semgrep is really you have a huge code base, and we want to write rules to make sure that the code base doesn't let a certain kind of bugs in, and just to warn. And so already, like if you have a tool that warn you about like bad patterns, basically, that's already big for most companies. and so yeah, another example. Here you're looking for calls to certain methods that you have this keyword argument in Python, AWS secret access key, and you want to make sure that you don't pass a string, a secret, basically, to them. And so here, if I click here, yes, so you have the pattern here. So you say, I want to find calls to boto3.client. I don't care about the first arguments, but at some point, I know there's a keyword argument and there's a value that is assigned a string, a constant string. So when you have ... inside a string, that means any string, right? And again, if you click run on it, it will find places where you call this function with string arguments. And actually, as you can see here, like Semgrep knows about the language, so it does simple constant propagation. And so, for example, here there was not a constant string, but it was a variable called someConst that was defined above that contained a constant string. And so Semgrep will do basic constant propagation, because the idea is that you write one pattern and we find all the equivalent variations of this pattern, all the semantically equivalent variation of this pattern. And actually here you can see that there was not a call to boto3.client, it was a call to b3.client. But again, it was the B3 was imported as a Boto3. And so again, Semgrep knows about the semantic of aliasing. It knows about constant propagation. I mean, it does perform some constant propagation. And in the same way, in Python, with keyword arguments can be written in any order, right? And so, and again, like here, actually, the secret access key was the first in the list, but will still match because we know you wrote the pattern with a key ID first, but really doesn't matter. Like the semantic of keyword argument in Python is that the order doesn't matter. So again, Semgrep will know about this and will find all the equivalent variations.
Yoann, I will interrupt you to read a question from the chat.
Yes.
Because Michele is asking if there is a large set of rules already in place, or is more about creating ad hoc rules based on patterns. I guess it means specifically patterns for specifically code-based or frameworks.
Yes, so there's a repository called Semgrep rules, actually, that is on GitHub with return to corp. And that's what I say about battery included, that there's like rules for Bash, for C, for C#, Dockerfile, Go, HTML. And each time you go inside, you will find some rule for Angular, for a framework. And so there's, when you install Semgrep, you can use these rules by default. And so there's already thousands of rules. I say hundreds of rules, but now that there's 1,000 of rules since. And so, yeah, people can use it without writing new rules and just rule the rules that we've provided. But like where Semgrep really, I mean, all the static analysis tools have a set of rules, right? But where Semgrep really shines, I think, is that you can customize those rules. You can write new rules that are specific to your code base. And so that's where Semgrep really shines. And so most of the time, the company starts with, oh, it's great. You find bugs with the rules from the community, but after some point, they write their own rules that will not apply to other code base because it's using internal library or framework that they've developed that would not make any sense in other companies.
Can I ask you if you're also encouraging the creators of different frameworks to create corresponding rules for Semgrep? Or?
Yes, not yet. I mean, we are not, but yeah, in the long term, that would be great. Yeah, that people, each time you have a new framework and you have some guidelines, instead of writing the guidelines in English, it would be great if it was formally specified with a Semgrep rule. Yeah, but no, not yet. There's not. I mean, there's a few people like there's Damian Grisky, which is like an important name in the Go community, that is writing Go rules, and so he's contributing to our rules. But not yet. Like Angular people maybe don't even know about Semgrep yet. I mean, we've been quite surprised, like the amount of people who know Semgrep already. Like we have salespeople in the company who reach to companies, and each time they, oh yeah, no, we already know Semgrep. Yeah, we already use the open source version of Semgrep. But yeah, indeed, it would be great at some point if like each framework will come with a set of rules that just specifies the guidelines.
So can I ask a quick question? What I assumed is that the way that you analyze the source code is like independent of each other in some way. Is that true? If it's true, does it cover the libraries that are included without the source code? I mean, like the jar files that we included in a project.
Yeah, so for Java, it will not analyze the dependent library because the goal is to find bugs in your code. So the rules are about your code, and so it's not about like finding. I mean, we actually have a product for detecting vulnerabilities in the dependent library, but I will not talk about that. It's quite different, but still, even for this product, like the idea is to analyze your code, not the code of third-party libraries.
Okay, thank you.
And so yeah, so the idea of Semgrep, you have these semantic equivalences. That is, Semgrep knows about the semantic of languages, And so it knows about keyword argument ordering, doesn't matter. It knows about import aliasing equivalence. It will perform constant propagation, symbolic expression propagation. It will also do data flow based chain propagation. It will know about the commutativity and associativity of certain operations. So if you're looking for 1 + 2, it will also find code that is written as 2 + 1 because it's semantically equivalent. And so it knows, I mean, that's the goal of the language, is to know about all the semantic of the languages, to write one pattern and find automatically all the semantically equivalent code. And so here on the example, yeah, I've repeated the example with the keyword argument, the aliasing, and the constant propagation. And so that was like the main feature, like the first two features of Semgrep, that you write code, you write patterns that looks like code. You can put the.
I have a question. How far does that semantic equivalence go? Because you can even have semantic equivalent algorithms. That's probably not how far you go, but how far does that go, and how do you define those semantically equivalent parts? Because that is for every language different, and I do know that it is quite a challenge to define to only define that already.
Yeah, I would say not far. It doesn't go that far. And so, but the idea is that we do the best to, like, each time we get feedback from developers and say, oh, it would be great if, like this, for example, like just this week, like someone was using Semgrep for Terraform, and in Terraform, like you can write, you can look for the pattern 42, the integers, but actually it's semantically equivalent to the string 42, and so there's no difference between string and numbers. And so we've added some semantic equivalence for Terraform, but that's just like we do as on a need basis, like feedback from developer. I mean, of course, it's like impossible. It's like impossible. It's like the alt decision. Like you can't decide whether two things are semantically equivalent, and so. But that doesn't mean we should not try to do something. Like it's like if we can't stay, this problem will go forever. But at least there's still static analysis tools that try to find bugs, and so we try. But that doesn't go very fast. That doesn't go that far. Sorry. Yeah. And so the first two features were, yeah, using the concrete syntax and the ellipsis operator. The other main features of Semgrep is the meta variable. And so here, for example, you want to find code that looks like where the two elements are of the comparison are the same, which is stupid code, right? You should never write like this kind of code. And so in Semgrep, the way you do that is that you use the $sign with an identifier after in uppercase, and that means that is a meta variable, and it will match any expression or any statement depending on the context. And so here, the pattern here is to look for $x == $x, and if you again run it, it will find all those places where the left and the right are the same. And so it can be quite complex expression. Here you have like a quite complex expression, and it's the same on the left and on the right, and the same here. And so it's a bit like I don't know if you're familiar with Prolog, but it's a bit like logic Prolog variable. That is like they must, when you use the same meta variable for the same thing, that means they need to unify in some sense. They need to be equal. And so that's meta variable. And so another example here that you want to enforce, that when you call make transaction, you call verified transaction before. And so here, this is good code, and here, this is bad code. And so again, if I click, the way you write this rule, so that is you want to find code that is where there's a call to make transaction with the meta variable $t, but is not a method where there's a verified transaction. That is because you put a is not, because this is okay. And if you do run, it will find these places. It will find these places also because you call make transaction before verified transaction, which is bad. It will find this place. It will not display this one because you did verified transaction. Sorry. It should find this one. No, why? Oh, there's a bug here.
But that is the correct one, while it should find the broken one, right?
Yes, actually, this, yeah, correct. So this is correct. So it doesn't match it. Bravo. So, but it's yes, it's this one because I don't see it. It will display this one at the end because it's you use a different transaction. There's a transaction T and it's another one. And so, but here you use exactly the same $T, and so it will not match. So, and so here you see another important feature of Semgrep is that you can write code pattern like this. And actually, here I've used meta variable also for the return type and for the name of the method because I don't care about those things. And then you can combine you can combine patterns together with Boolean formula. So you have this or, not, etc. And actually, this is like in the playground, you can click on the simple mode where like it's an easy way to write rules. But if you look to advanced mode, yes. A rule actually is stored in a YAML file, and a rule has an identifier, and then he has a set of patterns with you have this either and not. He has a message. He has a set of languages. He has a severity. So you can write a code pattern, but really you put your rules your patterns in a rule, and you can combine patterns together with a Boolean formula. And so yes, so the rule is that allows you a Boolean composition of patterns. Here you have like all the patterns in white, and you see they are combined in a formula with like this YAML key like pattern not inside, pattern either, pattern not, etc. And then once you store this rule in a YAML file, you can run a semgrep --config myrules.yaml and then your project, and then it will try to find occurrence of this rule in your file. Okay, I've seen there was a few questions, I think.
Yes, I didn't want to interrupt you to to the chance of making some progress, but there are a couple of questions. One from Michele that is asking for a comparison with SonarQube, like was suggesting from the perspective of a software manager that has to choose among this project. And then there is another question from Peter, but maybe we can go in order and focus on the question from Michele first.
What are the advantages versus SonarQube and similar more traditional SwiftLint? So like the advantage over SwiftLint, so I don't know SwiftLint, but I guess the advantages is that you learn once the principle of Semgrep and then you apply it to every languages. So you have a SwiftLint, you have a Bandit, you have a GoSec, you have each of these tools support just one language. And again, I don't know SwiftLint enough, but maybe my guess is that you need to learn the EST or of those languages to be able to write rules compared to SonarQube. So again, like the main idea of Semgrep is that you can write rules easily with just using like anybody can write rules. Basically, if you know the language you're working on, you can write rules for this language, which is quite different from like tools like SonarQube that you have to be a bit of an expert. And so yeah, for a software manager, like the selling point are that your developer will be able to customize to write their own rules. If you don't write any new rule, if you don't write rules, indeed SonarQube could be fine, good enough. I mean, now because it's so easy to write rules, now the community has written rules, so now we start to be better, to have a better set of rules than all these tools, because in some sense it's unfair. Like anybody can write rules, and so anybody can contribute. But if you don't want to write new rules, yeah, maybe SonarQube is good enough. Is there any plan to support automated bug fix transformation? Yes, there's some plans, and there's some actually the first step is to make it possible to fix code, and then automated bug fix transformation. That's again something else. But yeah, okay, I'll go forward. Yeah,
I think that once you have also the possibility of change code, then I would like to use this tool to implement transpilers, because if I can specify, when you see these, produce that, then
Yeah. I don't know. Maybe
next year.
So there's more feature. You can analyze embedded languages. Like it's quite frequent to have like SQL strings, for example, inside C code. And so actually with Semgrep, you can find first all the strings and then analyze the SQL that is inside the C. Or so you can analyze embedded languages. Like there's a tainting mode. There's lots of more features. So autofix. So like that's the example that people were mentioning, and so here we have like we want to find all the code to, in this time we're in Go, we want to find all the code to HTTP listen and serve, and so we write we learn, and it finds a place here where the address is 80 and the handler is nil, and actually you can write the autofix here. Maybe I go in advanced mode. So here this is a pattern. And then this is a fix. And if you run, it will find the pattern. And if you go there, you can actually apply the autofix. And you can see in the autofix, it's the HTTP, the 80, that is the content of the meta variable address, and then with what was specified. And so you write your pattern with meta variable, and then you write your fix that can reference meta variable that were matched by the pattern, and then it will apply the autofix. So here it's inside the playground, but here you apply the autofix. But if you are inside the command line, you can do semgrep -fix. I don't even remember the name now. And each rule can specify the pattern, the bug, and a way to fix the bug. And so that's the autofix. That's an important feature indeed. What are other features? So you can also, like, we don't like regex because they're fragile, but sometimes it's also convenient to use regex. And so, for example, here we want to find all the call to Boto3 client with the host, and we want to make sure that that we don't specify an IP address with numbers. And so you can use this pattern -regex so that you go back in the world of regex, but at least you go back to the world of regex in a very delimited context, that is the strings that was matched before by the more complex pattern. So you can do that. You can also use what we call typed meta variable, and so maybe I'll go to an example here. But here you're in Java and you want to find all the code to the exec method, but you want to restrict it to the class runtime. And so use $class, that is, you say, I don't care about that's the name of the class of this object, and then you restrict it to be of this type, runtime. And so if you click run, it will find these places because you have rt.exec, and rt was declared like just one line before as runtime. I mean, it will work also if it was defined on the parameter, and it will not display this one, other.exec, because this is not of the runtime type. And so just to prevent some question that might come, and so we analyze one file at a time, and so this typing is quite rudimentary. And so basically, if you use like if you have types, and also it works mostly for languages which have explicit types, and so like in Go, in Java, in C++, this kind of thing. For dynamic language, it's far more difficult to know the type of the thing, and so it will be quite limited. We do some work, or in Python, for example, people use MyPy, and so like more and more dynamic languages use gradual typing, especially in the Silicon Valley, in the industry, and so we can leverage this type annotation, but it's still quite limited. And so, but we try hard to propagate typing information in the program so that then when you use typed meta variable, oh, actually this place, we know the type of this expression, and so we can match it. And so that was typed meta variable. We also do some taint analysis, and so I will not have the time, but basically you can specify the source that will be a pattern, that is then you can specify the sinks and the sanitizer, and internally the tool will run a data flow analysis on your function or your method, and it will propagate the taint through the control flow. And so this is just intra-procedural. So it's not inter-procedural, it's not inter-file, it's just inside one function, but it's still like pretty useful because if you don't use taint, like your rule can be quite complicated. You will have, oh, there's a call to, I don't know, request.get to get a parameter from the web, and then you will ... but then inside it can be sanitized, and so you will have like lots of pattern ether, that is lots of disjunction. So like tainting rules allows you to simplify the rules, but still have like internally work on the semantic of the language and using a data flow analysis. Yeah, there was a question maybe?
Yes, there are 3 questions in the queue, but I wanted to make you to let you do some progress before interrupting. And there is a question from Ramon. He's asking if there are rules that consider comments.
No. So you can't analyze. I mean, we have so in the here you see you specify the language here, so you can put one of the 26 languages we have. You can also actually specify the regex, so that then your pattern will be a regular expression, and you can also specify what we call generic, which is a weird generic mode, like to analyze language generically, that know about parentheses and then indentation, that use parentheses and indentation. So it's a bit better than regex for certain things. And so if you wanted really to analyze those comments, you will need to go back to use regular expression, because when you write rules for a language, that's the idea of the tool, actually, to not care about the comments, to not care, like to actually just look at the code. And so I know that in Java, you have like those comments actually have some semantic a bit. You have Javadoc, and you might want to write rules that enforce you have Javadoc. This is not right now possible. You can actually, most of those languages now go away from comments and go towards annotation. And that's we analyze, because that's part of the language definition. And so if you use annotation, and in Java you have lots of annotation now in lots of in Python, also in JavaScript, TypeScript. So this you can write actually a rule that will find all the functions that have this special annotation.
Then
type
Antonio...
inference, so we do very limited form of type inference. I will be pretentious to call it type inference even, like it's not really, it's just like propagating a little bit. Now in some languages they also do some kind of local type inference. So but it's quite rudimentary, to be honest.
Then I think we have just a question from Antonio that was asking, when you were showing how to fix, if you can also specify rules to insert code before or after the element that you...
No, so the idea of so before I was working on Semgrep, long time ago, I made this tool called Coccinelle with Julia Lawal. And the idea is that you could specify, you had a domain-specific language to specify program transformation, reusing the patch syntax. So you could put minus and plus like in a patch everywhere. And so it was very flexible in the program transformation you could do. The problem is that it was just handling C, that as soon as you want to handle more languages, it was difficult to extend Coccinelle. And so the idea of when I did Semgrep, I went away from program transformation, because when you want to provide program transformation, like it's far more difficult to support many languages. And so what the way we have right now of the fix, it's very restricted. That is, you match an expression, or you match a statement or whatever, you match a place, and then you completely replace it by something else. And so if you wanted to add stuff before and after, you will have to just match it and then completely replace it by some code before, the code that was before and after. And so you can't express all the program transformation with this. And so, but again, the idea is like it provides good service for the users of Semgrep, and it covers lots of the program transformation they want. Because a big use case for Semgrep is like you want to enforce certain way to call API or to deprecate certain API, and so it's very often quite simple. Like you just want to match the argument, and there's a new argument to add, or you want to just rename the function, and so.
And maybe a question for myself. Looking at your presentation, I've been very impressed by the fact that you are supporting a lot of languages, but also performing not just parsing, but it seems to me that you're performing some symbol resolutions, data flow analysis, some sort. So I was wondering how much effort is to add support for another language in your system, because it's...
Yeah. So we still don't do very, very complex stuff like CodeQL or Coverity, and so it's not a lot of work to add a new language, because most of the work is actually on parsing, and then once you have the parsing, you need to transform the EST of your language in what we call the generic EST, which is more or less the factorized union of all those languages. And at the beginning, I didn't believe in it too much, but then I saw many projects doing. I mean, in the end, like, language have a lot in common, more than, like, they all look different, but in their core they have a lot in common. So if you look at Java and C#, they differ, but many of those features can be put in. So what we do is that we parse them and we convert them in the generic EST. And then all our code, all our engine works on this generic EST. So the naming, for example, import aliasing, you have it in Python, but it's almost the same in JavaScript. It's almost the same in Java, because all these languages actually copy each other. They copy feature from each other. Same in Scala, it's the same in. So once you have parse and you have this, you converted in the generic EST, all this naming and data flow and work was done for the generic EST. So you have it mostly for free. Of course, sometimes you add an exotic language that doesn't fit well. And so we need to move around a bit the generic EST, but usually it's not too hard to add a language, especially if the language is just different on the surface, but internally it's not that different.
I've got a sort of related question. How easy is it to do, I'm looking for the right way to say this, languages within languages? So for example, we use Java as the main language, but we also have templating languages, Velocity, and we have DSLs, draws. And the variable names in those templating language and in the DSL are also part of the variable names, except they're slightly different, because in one they're a bean and the other they're like a property name. How easy would it be to recognize that those belong together?
Yes, right now difficult, because each of these, like, templating language or framework or have like their own rules for naming. Indeed, like you use I don't know, EGS, like embedded JavaScript, or ERB, embedded Ruby, and indeed you can use name that reference the code from the view. That actually in Ruby it will be even like that convention that is, oh, it's a file in the same directory. So each of these framework will have some specific naming rules, and so it will be hard. What we can do right now, and what we work on right now, is that a way to first try to analyze the code that is in those templates. It's already, like, if we can do that already, that's nice. Like, then resolve names, that's a bigger problem, and we are working on that. But it's I don't have too much hope for this to make it like we could make it work for a few framework, the most important one, but to make it work in general, that will be hard. But yeah, templating language is a big problem right now. We have, like, actually we use Semgrep to specify way to extract the code from those template language, and then we can apply then the Java. For example, you have a GSP file with Java code inside. We write actually a Semgrep rules to match all the Java code inside this, and then we can just run Java rules on this extracted code. But it will not do. You will not be able to write a pattern that matches the template and the Java code at the same time.
Gotcha. All right, thanks.
Yes, and so go back to tint analysis. So slideshow. Actually, in the same context, like now, lots of things are defined outside the code in configuration file, in Terraform, in JSON, and so actually we don't just analyze code now, we analyze also those languages. And so you can, here on the left you have some JSON file, and then on the right you have here a pattern. And so JSON is actually JavaScript, and so you can match JavaScript code. Like here, this is a record in an object in JavaScript. And so you can write with this ... and etc. to match. So you can match also JavaScript, YAML code. Actually, we have the rules are written in YAML, and we have Semgrep for YAML. And so you can write meta checks. You can write checks that make sure that your Semgrep rules are well written. So it can go. And so, yeah, so that was Semgrep, the command line tool, and the playground that allows you to define rules. And then I'll try to go fast on it. But then there's a whole ecosystem around Semgrep. So there's what we call the registry, which if you go to semgrep.dev and you click on the registry, you can explore the rules that we have. So you can search. So for example, if you look for Java EC, and boom, it will give you all the rules that we have for Java. Then you can click on the rules and you can see the pattern and the code. You can explore. So we have a set of what we call rule sets or packs, which are, for example, here, there's a OWASP top 10. So OWASP is an organization that maintains guidelines for writing web application. And so there's a OWASP top 10 that are the top 10 bugs in OWASP. And so we've written, some people have written rules for that. So once you have this rule set, you can just use it on the command line. You can just do semgrep -- config with the name of this rule set. So p/OWASP.10, and then it will get it from the web. It will get the rules from the web and apply it on your project. So you don't even have to download it. It will take rules from the community. So that the registry, it's very easy to integrate in CI. And so we have Semgrep that runs in Docker. And so then you just like add the steps in GitHub Action or Circle CI or your favorite CI system. And then that's it. You write this, you copy paste those few lines. And then each time a developer in your organization will commit code to a repository, it will run the Semgrep rules that you've defined. And actually, it's we have good integration with GitLab and GitHub. And so, for example, for GitHub, when Semgrep will run, it will also comment on the pull request. And so here, some people made a pull request on a repository, and then we run the Semgrep will run some rules in CI and then report it and say, oh, you should not call this. And actually, like I've talked about the fix, the auto fix feature before. And so actually, even the Semgrep itself will propose the fix automatically. So then the developer can just commit the suggestion and so and get on with his life. And so this is very important. I mean, developer used to hate static analysis tool. And so when we started, like, you had the AppSec people, the application security people who want to enforce rules. And then you had the developers that because those tools were too many false positives, they didn't find them useful. And so when you provide a fix, that's a huge way for them to not be mad at you. That, okay, they found something, there's automatically a fix, that's nice. So that's quite important to be well integrated in the workflow of people. And so that's pull request. And we also have a SaaS application, so that then so you were talking about a software manager before, like a software manager can use the SaaS tool and then can configure the rule set to run on all these projects. And so there's a dashboard, you can see the list of projects. There's a rule board, that is, you can move around like the rules to apply. So here you have like a CI rule set, XSS rule sets. You can make them block. You can make them just comment. You can make them just audit for the security people. So I will not talk too much about the SaaS application, but there's a Semgrep open source tool, and all around there's an ecosystem to make it easy for manager and for developers to deploy them, deploy it on their code. So that very, very quickly the developers learn about Semgrep, they start to write a few rules, and then very quickly they can put it in the organization. And so why do people like Semgrep? And so this is actually, someone was talking about SonarQube before. So this is like the evolution of GitHub stars. So this is an old slide. So actually we went above SonarQube. So we are now at 7,500 GitHub stars. it's one metric. It's not the best metric, but that's the only one we have right now. And so Semgrep is made a good progression. And the other was CodeQL, which is another tool by GitHub to do static analysis, but it's far more complicated to use. And so you see the progress is far slower. And so why do people like Semgrep? And so because it's fast, that is run very quickly on your big code base, because it's easy to parallelize. Basically, we just analyze one file at a time, and it doesn't take long in CI. So if you look at tools like Coverity, Fortify, they will take 1 day, or maybe let's add best case like a few hours. That's already bothering people. Like they don't want to be bothered and to wait 1 day to make sure to wait for their code to be committed. And those tools cannot even be used in the editor. So Semgrep can be used in VS Code or JetBrains or whatever, or in Emacs, or the command line. So you don't need like a special things to run it. And why do people like it? Because it supports most languages. So we support 26 languages, so most of the popular one. And it takes few weeks to add a language in general. And so it's far harder for CodeQL because they try to do, because I mean, sometimes they're a real static analysis tool. They try to do correct naming. They need to analyze a project globally. So they need to resolve each name. They need to understand the external framework. They need to, so they need the code to compile also. So there are far more constraints. But the thing is that in practice, it works pretty well, like, because now the bugs that you want to find are simpler in some sense. It's just like enforcing certain rules on your code. And so it's, and it supports also configuration files. So Docker, Terraform, YAML file, JSON file. It's easy to set up, and it's easy to customize. So you can, the rules are readable. Like if you want to know what are the rules written by Snyk or Coverity, you can't. They have a list of like identifier, but it's hard to know. And compared to Swiftlin that was mentioned, so you learn the principle once, the principle of Semgrep, that is the meta variable, the ... and then you can apply it to all the languages you know. I have a few slides for talking about language engineering. That was supposed to be the main focus of the talk, but yeah. And so, so internally, Semgrep relies on the tree-sitter library to parse code. And so I think a few of you are familiar with it. And so at the beginning, actually, I wrote the parser for many of the languages. So when I was at Facebook, I wrote a PHP parser using Yak, basically. I mean, it was in OCaml, so it was in OCaml Yak, but it's the same idea. And so I wrote a parser for PHP, for Java, because people wanted to find bugs on Java. So I developed lots of parsers for many languages, but then it's hard to scale, right? It's fine for when you are inside a company, because the company doesn't use the latest version of Java, doesn't use they don't upgrade that often. But when you want to support like hundreds of thousands of companies, they actually use the very latest version of Java, the very latest version of Go. So you need to keep up to date with all these languages that evolve. And so that's when we started to look at alternatives to write ourselves the parser. And we find this tree-sitter project by GitHub that is powering github.com, the now defunct editor Atom, NeoVim. So there's a few projects that use tree-sitter internally. Some of the VS Code plugins actually are now using tree-sitter. And so what is tree-sitter? So it's a GLR parser generator, so a generalized LR. And there's inside, there's no, I can maybe show you just quickly. So this is, so if you go to tree-sitter, you see you have like tree-sitter JavaScript, tree-sitter Python, tree-sitter Go. So there's one project per language. So you go to tree-sitter Go, and then you have this file called grammar.js. So it's a bit weird at first, because the grammar are written in JavaScript DSL, basically. So but here you have the grammar for Go. And so you have this name Go, you have some extra, you have some conflict, because you can have conflicts in GLR. And then you have your rules. So your basically extended BNF rules. You have your package, your import, and then you can use these tokens directly. You can use these open parentheses directly. And so you have your grammar specifying this JavaScript DSL. but there's no, it's just parsing, right? There's no action like in Yak where you will build an EST. And so but so it does less than Yak in some sense, where you can build, where you can make action to build the EST, but at the same time, that means it works for, it doesn't work just for, you can use it in any language. And so you can use it, Camel, in Scala, in Python, because it doesn't do a lot. It just do a GLR parser generator. And from that, you get a concrete syntax tree for your language. And so there's many bindings. That is, you can leverage tree-sitter from many languages. And it supports more than 40 programming languages. So there's lots of grammars. And so it's a small community, but it's pretty active. And each language, I would say, have 2 or 3 regular people who commit code, who adapt it. So it's not a lot, but it's surprisingly enough to keep up to date with this. I mean, the language evolved, but not that often either. And so if you have a small community, and so that was a very, because in the team, we were like, for a long time, I was just myself working on it. And then now we are like 6 people maintaining the open source tool. And so that was hard to scale to 26 languages. And so at least now we leverage all the work done by the community. And on top of tree-sitter, we developed this binding called OCaml tree-sitter, which is a tool to help generate typed EST from untyped CST. And so we made this special tool for OCaml. And so now we can just leverage all the concrete syntax tree from all those languages. And so here I have like a very basic architecture view of how Semgrep works internally regarding parsing. And so on the left, you have the source code. And so, for example, you have a file foo.js. And so it's parsed by tree-sitter using the GLR parser in a concrete syntax tree. Basically, in JSON, you have a JSON tree of the concrete syntax tree. And then we transform that internally ourselves in a JavaScript EST. And then we have this generic EST here, where all the languages convert to this generic EST. And on the right, we have the patterns, where basically we just extended slightly the grammar of all those languages to support ... at a few places, to support meta variable at a few places. So basically, we reuse the grammar of the language, just extend it very, very little, and then we parse the pattern like we will parse the code. And so on the right, we have the pattern that is also translated into a generic EST. And then you basically have a generic EST for the pattern, a generic EST for the target code, and then you just visit it, and then each time try to find a match. And so that's very high level view, yeah, this is the same thing basically. And so that's parsing. So the parsing is that we use tree-sitter now for most of the languages. We get a concrete syntax tree, we convert to the generic EST, and then once we have the generic EST, we do some naming, that is resolving names. And so here I've got an example where you do let a equal 1, and then you have a function foo, and then you have a local variable let a equal 2, and then return a. And if your pattern is $x equal 1, return $x, it will not match this code, because even though you use a, that was the same, this is not the same a. Like the global variable a and the local variable a have the same name, but the meta variable doesn't work at the text level. They work at the semantic level. And so we do some basic name resolution. And so when you use the same meta variable at different places, you are guaranteed that the scope, you talk about the same variable. And so regarding typing, like we do basic declaration propagation. So once you declare the type of something, we remember it, and then we can propagate information. And then we have once we have the generic EST, and then we convert it to an intermediate language that we call IL. And we have a CFG, that control flow graph, and that's where we do the tainting and the more advanced constant propagation. And so that's a high level view. And so what are the future work? So an important future work is what we call now deep Semgrep, which is a proprietary extension of Semgrep. But the idea is to not just analyze one file at a time, but to analyze multiple files at the same time and to do some global analysis. So the idea is you can use deep Semgrep and use the same rules. You will use exactly the same rules. There's no need to change the syntax of the rules, but internally the engine will be better because it will not just do intra-file constant propagation, it will do inter-file constant propagation, which is especially useful for languages like Java or C# where people tend to spread around things in many, many different files. The same thing for typing. You have type and meta variable that are good for when the things are local, but some things are defined in different files. So we will do inter-file typing propagation. We will do inter-file tainting. We do, and so Deep Semgrep is actually. I mean, we should release it very, very soon. Actually next month. So it's slower, but you will have less false positive and less false negative. Another future work is that we are like YAML is a very nice language at first for newcomer, but there's lots of very bad edge cases as soon as you start to use it. And so one thing I'm working on actually currently is to switch from YAML to JSONet. So probably you're not familiar with JSONet, but JSONet was a language, a very nice language defined by Google with a very nice semantic, very clear specification. The specification is, I mean, I don't like formal languages and formal work in general because I think, but it's actually there's a formal semantic and formal syntax definition of it that is very, very nice. And so, and the idea is that because you cannot template a YAML, I mean, it's just madness to try to do that. And so sometimes you have rules and you want to factorize elements in a rule. And so that's where I think JSONet will be better than YAML. And future work, there's more languages, more feature, etc. And so, yeah, last but not least, we are hiring, and so we are a small startup. But if you love OCaml, if you love program analysis, or if you know students who love OCaml, who like program analysis, or who have a passion for dev tools or security, contact me. And that's it. Thanks.
Thank you for the great presentation. And just about the last slide about hiring, just to confirm that you're looking for language engineer everywhere, right? You're not looking for them in the US, in Europe.
No, yeah. It's, I mean, right now, this slide's a bit old. So like, I don't know if you're familiar with the economic situation in the world, like most companies are firing actually.
I've heard something.
Yes, yes. So most companies are firing. And so we're also a bit tight on money, but we are starting to hiring again. So yeah.
Good.
And yeah, we hire remotely. So actually most of the, yeah, we have, I'm from Italy. One of the other people in my team is in Spain right now. We have people in France. Actually, we have an Italian living in France and a French living in Italy.
Swap, nice. Good. This has been amazing, and you answered a lot of questions, but I think there is another one from Paul that I think would be interesting to cover, that was asking small details, but what about the languages that have used the 3 dots as part of their languages, like Python?
Yes, that's a problem. So, right now you will not be able to find you will not be able, I mean, when dot is in the target language, you will not be able to match it. And so you can write, when you will write a pattern with dot, I mean, it depends on the context, because sometimes dot is allowed just in certain contexts in the target language and not in other. And so then there's no ambiguity. So for example, in dot can be used, I don't know, in import. Python doesn't allow dot in import, but we allow it. And so then there's no problem because it was not in the target language. When something is ambiguous, in that case, like we interpret it as the pattern takes precedence over the target. So the dot will be interpreted as the dot from the pattern. And so you will not be able to match 1.10, I think, maybe in Python.
Yeah, and I wanted to.
We should allow a way to escape it, and so actually, there's an issue about this, I think, and we never fixed it. We never found the syntax to, like, we should allow like maybe anti/dot to escape it or something, but it never came enough so that we took the time to fix it.
Yeah, sufficiently rare.
And yeah, for PHP. Yeah, for PHP for dollar, so the meta variable have to be in uppercase, and actually most PHP code when they use dollar variable, the variable is in lowercase. And so we have exception like request is like there's a few special variable in PHP like $request, $get, so that we know about those for PHP. And so in that case, they are not meta variable that we know that the person wants to match really $request, not is not a meta variable. Yeah.
Good. And I wanted also to say that I found this particularly interesting because as part of our work, we write a lot of transpilers, and until now we wrote the rules to do transformation defining, DST programmatically, and we are now experimenting with a sort of similar approach, way more primitive than yours, in which we specify examples, works as sort of templates, and so it's nice to see this idea actually applied correctly and see that works. It's inspiring for what we are also trying to do.
Like many of the ideas can be traced back to Coccinelle, that introduced meta variable, that introduced ... that actually was more powerful. And actually, when I independently, then I realized that JetBrains actually had something called structure, search, and replace, which is quite similar. Like there's a very advanced feature in JetBrains where you can that is called SSR, for structural search and replace, where you can write patterns where like you do using the concrete syntax and using meta variable and so on. So it's not as flexible as Semgrep, but it's pretty powerful also.
Good. So I think that we took a little more time from our presenter that we agreed to, and we had a lot of questions. So
I'm fine. If there's more question, I'm fine. Or maybe people want to leave. I mean, the only problem is my wife and my kids. But right now they are not yelling, so I guess they're
so
fine. I'm just looking at the chat and some of the questions I didn't answer, but.
So I don't know if anyone has one final question. And if not, I think it's time to thank all the participants. And Yoann, congratulations for the amazing work and for the amazing presentation. We really enjoyed it.
Thanks for the invitation, and thanks for the community.
Thank you.
Bye.
Goodbye.
Bye.